4.5 trillion miles from the terrestrial warmth we take for granted, the concept of daylight ceases to exist. Out here, the sun is no longer a blinding sphere of life-sustaining energy. It is reduced to an anonymous pale point of light, virtually indistinguishable from the suffocating backdrop of the Milky Way. The temperature hovers mere fractions of a degree above absolute zero, a cold so severe that molecular motion is practically paralyzed. The vacuum is so profound, so utterly devoid of scattered photons, that a human eye would register nothing but absolute, crushing blackness. This is the terminal edge, the gravitational graveyard of our solar system, a theoretical, spherical shell of primordial ice encasing our planetary neighborhood, stretching halfway to the nearest neighboring star. For decades, the mathematics of orbital mechanics dictated that this distant frontier was essentially a barren wasteland. It was modeled as a ghost town of scattered microscopic debris, exiled during the violent and chaotic construction of the early planets. The distances between objects in this region were calculated to be incomprehensibly vast. Tens of millions of miles of empty, frozen nothingness were expected to separate a single dormant chunk of ice from its nearest neighbor. We conceived of it as a diffuse, silent halo, a convenient mathematical necessity, a placeholder to explain the occasional rogue comet that plunges toward the inner solar system every few millennia. We mapped its hypothetical coordinates in our textbooks and accepted that it was merely the fading, empty echo of our sun's gravitational authority, a quiet perimeter where the solar system gently dissolved into the interstellar void. But the architecture of human perception fundamentally changed the moment a beryllium mirror, coated in microscopic layers of gold, was calibrated 1 million miles from Earth. This machine was not engineered to capture visible sunlight. It was designed to feel, to detect the microscopic ancient heat bleeding out of the coldest, darkest corners of the universe. When the mission control sequences commanded this instrument to peer away from the bright, chaotic nurseries of distant galaxies and focus instead on the pitch-black, seemingly empty spatial coordinates just beyond the Kuiper Belt, the telemetry began to break our long-held assumptions. The incoming data packets did not describe a sparse, quiet halo of isolated ice. The sensors began registering relentless anomalies. Faint, ghostly pulses of infrared radiation were seeping through the frozen dark, painting a thermal landscape where our models predicted an absolute void. The shadows stretching across the spectroscopic readouts indicated a structural complexity, a sheer mass and a population density that completely defies the established laws of how our outer solar system formed. The implications of these thermal maps are immediate and chilling. Every pixel of unexpected data returning from the deep infrared spectrum represents massive physical objects that have been lurking in complete stealth since the dawn of the solar system. Bodies of ice, rock, and ancient matter locked in a slow, silent orbit that has remained entirely invisible to optical astronomy for centuries. We assumed we were living in a relatively clean, cleared-out planetary system, protected by the vast, empty distances of deep space. But the infrared telemetry reveals that the frozen perimeter is not a void. It is a densely populated ocean of ancient mass, and the data is finally illuminating the true scale of what has been quietly circling us in the dark. To understand the gravity of what the thermal data is now showing us, we must first dissect the fundamental flaw in how humanity has observed the cosmos for 400 years. Our entire relationship with the universe has been defined by a deep biological bias. We evolved on a warm rock, huddled dangerously close to a blindingly bright star. Our eyes adapted to process high-energy photons, and so we built our instruments in our own image. From the earliest glass lenses polished in the 17th century to the massive observatories crowning our mountains today, we have demanded that the universe reflect visible light back to us. But the outer solar system does not care about our biological biases. It is governed by a merciless geometric reality regarding how light travels through a vacuum. The mathematics of illumination reveal a crushing truth. As a beam of sunlight travels outward from our star, it does not simply fade in a straight line. It dilutes outward in 3 dimensions, spreading its finite energy across an ever-expanding invisible sphere. By the time the sun's photons cross the orbit of Neptune, they have been stretched and starved into a pale twilight. But to reach the inner edge of the Oort cloud, that light must travel thousands of times further. When those exhausted photons finally strike a chunk of primordial ice hanging in the deep void, they barely register. And for us to see that object using an optical telescope on Earth, those surviving photons must bounce off the dark, carbon-stained surface of the ice and survive the entire excruciating journey back to our lenses. It is the equivalent of standing in a canyon at midnight, shining a dying flashlight at a black wall 100 miles away, and expecting the reflection to blind you. This is why the edge of our solar system has always appeared empty. It is not that the void is unoccupied. It is simply that optical physics guarantees our blindness. Because we could not see the edge, we had to deduce its existence through mathematical autopsies of the dying bodies that occasionally fell from it. In the middle of the 20th century, astronomers began meticulously tracking the trajectories of long-period comets. These were massive, ancient, city-sized blocks of dirty ice that would suddenly plunge into the inner solar system, swing violently around the sun, and bleed a tail of vaporizing gas before being flung back into the dark. When physicists reverse-engineered the orbital mechanics of these frozen wanderers, they noticed a disturbing pattern. These comets were not coming from the flat, orderly plane where all the planets reside. They were plunging in from every conceivable angle, from the top, from the bottom, from all sides of the solar system. The geometry of those incoming orbits painted a definitive mathematical ghost. The only way comets could attack the sun from every possible direction was if our entire solar system was completely encased inside a colossal, three-dimensional sphere of debris. The math proved the existence of the Oort cloud long before we could ever hope to see it. But the numbers also offered a false sense of comfort. Because these comet incursions were relatively rare, the equations suggested that the reservoir was heavily diluted. We built our theoretical models on the assumption that this spherical graveyard was sparsely populated, a desolate borderlands where objects were separated by millions of miles of empty vacuum. We assumed the deep dark was mostly just that, dark. That fragile illusion was completely dismantled the moment we stopped asking the universe to reflect light and started building machines capable of sensing ancient heat. The James Webb Space Telescope does not look for the sun's reflection. Its massive segmented mirror is forged from beryllium, a rare metal chosen specifically because it holds its shape at temperatures that would shatter normal materials. It is coated in microscopic layers of gold, engineered to act as a perfect snare for infrared radiation. But to detect the faint, agonizingly weak thermal pulse of a frozen object trillions of miles away, the machine itself must be dead to its own heat. It is parked in a stable gravitational pocket far from Earth, protected by a multi-layered sunshield the size of a tennis court that permanently casts the telescope into a deep freeze. Its sensors are actively drained of heat by mechanical cryocoolers, forcing the instruments down to temperatures hovering just a few degrees above absolute zero. From this state of artificial hypothermia, the telescope opens its golden eye to the outer perimeter, and the physics of the void flip completely upside down. At absolute zero, nothing moves, but out in the Oort cloud, the ambient temperature is marginally higher than the cosmic background radiation. The ancient ice and rock out there hold a tiny residual warmth, an echo of the solar system's violent birth. To an optical telescope, 1 trillion tons of frozen methane and rock at the edge of the sun's reach is perfectly invisible. But to a supercooled infrared sensor operating in the deep vacuum, that same frozen mass glows like a dying ember in a pitch-black room. By filtering out the blinding interference of starlight and focusing purely on the longest wavelengths of thermal radiation, the instruments bypass the fatal flaw of the inverse square law of light. They are not waiting for the sun's reflection. They are capturing the internal microscopic vibration of the matter itself. And what the thermal mapping of the deep solar system is beginning to expose is not a sparse, elegant halo of scattered debris. The infrared signatures suggest a crowded, chaotic architecture. Massive, dormant bodies, some potentially rivaling the size of our own moon, suspended in the dark. The gravitational models that once painted a quiet, desolate frontier are being rewritten by the sheer volume of mass that is suddenly radiating on our spectroscopic readouts. The barrier between our planetary neighborhood and the interstellar medium is not an empty, fading boundary. It is a dense, heavily fortified wall of ancient matter, quietly orbiting our sun in the absolute dark, waiting. We are only just beginning to map the true scale of the abyss that surrounds us. The universe is cold, it is indifferent, and it is far more crowded than we ever dared to calculate. If you seek to understand the raw, unedited reality of the cosmos, and if you have the quiet resolve to look into the dark without demanding comforting answers, subscribe and join us as we journey further into the void. To fully grasp the nightmare of scale that we are dealing with, we must first abandon the fragile, compressed maps of the solar system we were handed as children. Those diagrams, with their neatly spaced rings and brightly colored planets, are comfortable lies. They compress the terrifying geometry of the void into something a human mind can digest without experiencing a profound sense of vertigo. If we want to understand what the data is actually telling us about the deep perimeter, we have to rebuild our perception of distance from the ground up, using the only currency that matters in the dark, the speed of light. When a photon is born in the nuclear furnace of our sun, it races outward at 186,000 miles per second. It takes just 8 minutes for that light to cross the 93 million miles to strike your face on Earth. We call this distance 1 astronomical unit. It is the fundamental yardstick of our neighborhood. At this speed, sunlight brushes past the rust-colored deserts of Mars a few minutes later. It takes just over 40 minutes to illuminate the turbulent gas storms of Jupiter. In a little over 4 hours, that same light finally reaches Neptune, the last major planet, standing at roughly 30 astronomical units away. For centuries, human intuition drew a line in the sand right here. We assumed Neptune was the border, the edge of the map. But the true architecture of our solar system stretches so violently far beyond Neptune that the human brain lacks the biological hardware to properly visualize it. Consider the Voyager probes. Launched in the late 1970s, these twin machines are the fastest and farthest man-made objects in existence. For nearly half a century, they have been tearing through the vacuum at over 30,000 miles per hour, fleeing the sun relentlessly, day and night without pause. They have crossed the termination shock. They have punched through the heliopause, the invisible magnetic bubble where the solar wind violently collides with the interstellar medium. They are, by all technical definitions, sailing through the uncharted waters of deep space. They are currently over 160 astronomical units away, but the terrifying mathematical truth is that despite traveling at hypersonic speeds for decades, the Voyager probes have not even reached the starting line of the Oort cloud. Based on the gravitational trajectories of incoming long-period comets, astrodynamics dictates that the inner edge of this frozen shell does not begin until at least 2,000 astronomical units from the Sun. That is 2,000 times the distance between the Earth and the Sun. It will take the Voyager probes another 300 years of relentless flight through the absolute dark just to reach the absolute inner boundary of this debris field. And even then, their journey through the graveyard will have only just begun. The outer edge of the Oort cloud is calculated to extend outward to 100,000 astronomical units. That is nearly a quarter of the way to the next closest star system, Alpha Centauri. To put that into a physical perspective, if you were to fly a commercial jet airplane constantly at cruising speed, it would take you over 4 million years just to cross from one side of this shell to the other. It will take the Voyager probes 30,000 years to fly through it, 30,000 years of moving at 30,000 miles per hour just to exit the gravitational jurisdiction of our Sun. Within this incomprehensible volume of space, the models predict a population of icy bodies that borders on the absurd. We are not talking about thousands or millions of objects. The mathematics of orbital dynamics require billions, perhaps trillions of individual bodies larger than a kilometer across, suspended in the dark. These are not pristine white snowballs. They are ancient, irregular mountains of primordial matter. They are forged from the volatile building blocks of the early universe. Water ice, frozen carbon monoxide, solid ammonia, and methane, all baked in a thick, dark crust of complex organic compounds slowly irradiated by cosmic rays over 4.5 billion years. They are the pristine, untouched leftovers of planetary construction. But the sheer volume of the Oort cloud creates a terrifying paradox of density. If there are trillions of massive objects out there, why have they not collapsed into a new planet? Why are they not violently colliding with one another, grinding themselves into dust? The answer lies in the terrifying emptiness of the math. The volume of the spherical shell they occupy is so astronomically vast that even with trillions of mountains floating within it, the distance between any two objects is staggering. It is estimated that you could place the Earth right in the middle of the Oort cloud, and the nearest chunk of ice would be tens of millions of miles away. It is an ocean populated by trillions of islands, but the islands are so isolated that they will never see each other. They orbit the sun in total perpetual isolation, locked in a silent, freezing dark, where the sun is nothing more than a particularly bright star in a tapestry of billions. The physical mechanics of how these objects got there is a brutal story of planetary eviction. 4.5 billion years ago, the solar system was not the stable, clockwork mechanism we see today. It was a violent, chaotic disk of gas and dust. As the massive gas giants, Jupiter, Saturn, Uranus, and Neptune, began to rapidly form and shift their orbits, they acted like catastrophic gravitational engines. They bullied the smaller, icy debris of the protoplanetary disk. When a primitive chunk of ice drifted too close to the immense gravity well of a young Jupiter, it was not always swallowed. Often, the physics of momentum acted like a slingshot. The ice was caught in the giant planet's gravitational grip, accelerated to terrifying speeds and violently ejected outward. Billions upon billions of these bodies were fired into the deep dark like cosmic shrapnel. Most of them were blasted completely out of the solar system, doomed to drift through the Milky Way as rogue interstellar orphans forever. But a fraction of them, perhaps a few trillion, did not quite reach the escape velocity required to break the sun's hold completely. They were flung incredibly far, cast out to the very absolute limits of the sun's gravitational reach, but their momentum eventually ran out. They slowed down, halted in the deep freeze of the void, and began a slow, agonizingly long orbit back around the star that rejected them. This is the origin of the Oort cloud. It is a spherical quarantine zone of exiled worlds held together by the weakest possible invisible thread of gravity. At 100,000 astronomical units, the mechanics of gravity are stretched to their absolute breaking point. The sun's influence is so fundamentally weak out here that the objects in the outer Oort cloud barely belong to our solar system at all. They are drifting on a razor-thin mathematical line between remaining tethered to our star and being stolen away by the void. Because the sun's grip is so frail, these distant mountains of ice are highly susceptible to the microscopic gravitational whispers of the galaxy itself. The mass of the Milky Way disk exerts a subtle, continuous pull, a phenomenon known as the galactic tide. Over millions of years, this gentle tide physically warps the orbits of these distant objects, pulling them away from the flat plane of the solar system and scattering them into the colossal three-dimensional sphere we calculate today. Furthermore, the solar system is not stationary. We are hurtling through the Orion arm of the Milky Way at 500,000 miles per hour. As we plow through the interstellar medium, rogue stars, molecular clouds, and unseen masses constantly pass by our solar system. Because the objects in the outer Oort cloud are so loosely bound to us, even a star passing light years away can send a gravitational ripple through the dark, acting like a phantom hand that nudges a trillion-ton block of ice just a fraction of a degree. That microscopic nudge is all it takes. Once perturbed, the object loses its fragile orbital momentum and begins a slow, silent, and fatal fall back toward the inner solar system. A fall that takes hundreds of thousands of years to complete. A fall that transforms a dormant, invisible mountain of deep space ice into a blazing, violent comet tearing across our night sky. Every comet we have ever witnessed in human history is essentially a distress signal. A dying ember screaming across the inner solar system, serving as undeniable mathematical proof of the colossal, unseen reservoir hovering silently in the dark. We have always known it was there, but knowing the numbers on a chalkboard is profoundly different from finally possessing the technological capacity to map the thermal ghosts of the void. The deeper we venture into the data returning from the frozen perimeter, the more violently we collide with a harsh, unyielding wall, not of ice, but of mathematics. The Oort cloud is not merely a physical graveyard of primordial matter, it has become a theoretical crisis. A place where the pristine, clockwork equations of celestial mechanics, which have successfully guided human astronomy since the era of Isaac Newton, begin to warp, stutter, and push our current understanding of physics to the absolute point of exhaustion. The first fundamental impasse we encounter is the absolute nightmare of observational verification. In mainstream science, a theory requires empirical, repeatable proof to survive, but the physical reality of the outer solar system seems almost maliciously engineered to deny us that proof. To study an object, we must measure its interaction with energy, we must capture its light, map its gravitational pull or analyze its radar reflection. But at 50,000 astronomical units, the universe introduces a barrier of sheer crushing scale that renders our most advanced technology functionally useless. Consider the problem of active detection. If we cannot see these frozen mountains by the dying, starved light of the sun, the logical alternative would be to illuminate them ourselves. We could, theoretically, fire a colossal burst of high-energy radar waves from our largest planetary transmitters directly into the dark, waiting for the signal to bounce off an Oort cloud object and return to Earth. But the mathematics of radar propagation contain a terrifying mathematical law known as the radar equation, governed by an inverse fourth-power relationship. This means that as a radar signal travels into the deep void, its power drops dramatically with the square of the distance. But for the reflection to be useful, that already exhausted microscopic whisper of a signal must then travel the exact same distance back to Earth, diluting its energy by the square of the distance yet again. When you multiply those equations across the vast gulf separating us from the perimeter, the math reveals an uncompromising truth. If you were to blast a radar signal with the power of a thermonuclear detonation into the inner boundary of the Oort cloud, the returning echo would arrive back on Earth centuries later, reduced to a fraction of a single photon. It is a signal so infinitesimally weak that it is completely indistinguishable from the background hum of the quantum vacuum. The universe has built an invisible, energetic wall around our solar system, ensuring that we can never actively probe the dark. We can only sit in the quiet, passive dark, waiting for the shadows to reveal themselves. This observational blindness forces astrophysicists into a state of profound, systemic frustration. We are trapped in a position where we must calculate the architecture of our outer solar system using indirect, circumstantial evidence. We are like detectives trying to reconstruct the layout of a massive, crowded mansion by looking exclusively at the dust patterns left under the doors. Every calculation we make regarding the total mass, the distribution, and the exact boundaries of the Oort cloud is entirely dependent on computer simulations and the hypersensitive tracking of the rare comets that manage to escape the graveyard. But when we attempt to reconcile these computer models with the actual observed universe, a glaring, deeply unsettling paradox emerges. The math simply does not add up. When astronomers run state-of-the-art simulations, tracking the birth of our solar system, charting the chaotic gravitational dance of Jupiter and Saturn as they violently purge the protoplanetary disk of its primordial debris, the equations consistently predict a specific, massive density for the resulting Oort cloud. The simulations dictate that there should be enough expelled matter out there to form a colossal, heavy shell weighing multiple times the mass of the Earth. But when we look at the actual historical frequency of long-period comets entering our inner system, and when we map the faint, ghostly thermal anomalies recently captured in the deep infrared spectrum, we find a massive, unexplained deficit. The observed universe appears to be missing a staggering amount of mass. The equations tell us the outer perimeter should be heavily fortified with ancient matter, but the observational data hints at a hauntingly sparse reality. This discrepancy is known in astrophysics as the fading problem, and it represents a deep, unhealed wound in our understanding of cometary physics. To resolve this paradox, scientists are forced to confront highly uncomfortable theoretical possibilities. One hypothesis is that our understanding of how comets behave is fundamentally broken. It is possible that the vast majority of these primordial mountains do not survive their long, agonizingly slow hibernation in the deep dark. They may be disintegrating, crumbling into invisible clouds of microscopic dust under the constant, relentless bombardment of high-energy cosmic rays from deep space, long before they can ever fall back toward the sun. Another, more radical possibility is that our standard models of planetary formation are missing a massive hidden variable. We may be fundamentally wrong about the early history of our own home. This theoretical frustration is compounded by a terrifying logistical barrier, the absolute limitation of human spaceflight and longevity. To truly solve the mysteries of the perimeter, to validate our conflicting mathematics, we would need to send a machine out there. We would need a robotic scout to navigate the frozen graveyard, to taste the primordial ice, and to broadcast direct, unedited telemetry back to Earth. But the physics of propulsion and energy preservation have locked us in a permanent technological quarantine. Our current premier deep space probes rely on radioisotope thermoelectric generators, small rugged nuclear batteries powered by the natural radioactive decay of plutonium-238. This technology is incredibly reliable, keeping the Voyager probes alive for nearly 50 years in the freezing vacuum. But radioactive decay is governed by an absolute, unalterable half-life. Plutonium-238 decays at a rate that cuts its power output in half every 88 years. By the time a spacecraft traveling at our maximum achievable velocities cruises past the inner absolute threshold of the Oort cloud, 300 years from now, its nuclear heart will have long since gone cold. The electronics will be dead. The transmitters will be frozen silent. The camera lenses will be blind. The probe will not be an explorer. It will be a floating metal coffin drifting silently through a graveyard of ice, completely incapable of telling us what it sees. To build a machine that can survive the journey to the edge of the sun's authority, we would need to engineer systems capable of functioning continuously for thousands of years without maintenance, powered by energy sources that do not yet exist in our vocabulary of physics. And even if we could somehow solve the crisis of propulsion and longevity, we would immediately face the terrifying reality of cosmic latency. At 50,000 astronomical units, a radio signal traveling at the absolute speed of light would take nearly a year to complete a one-way trip back to Earth. If a probe navigating the outer Oort cloud encountered a catastrophic orbital anomaly or a sudden unexpected mass, it would take 12 months for its automated distress call to reach our ground stations, and any command we broadcast in response would take another year to arrive. By the time our instructions reached the spacecraft, the event would have concluded centuries prior. At this scale, the concept of real-time exploration completely disintegrates. The edge of the solar system is not just distant in space, it is distant in time. We are left standing on a fragile platform of theory, looking out into an abyss that actively resists our curiosity. The mathematics that allow us to calculate the existence of the Oort cloud are the exact same mathematics that prove we may never be able to fully touch it, see it, or comprehend its true nature. We are locked in a cage of light and time, staring at a frozen, heavy boundary that marks the absolute limit of human ambition, a boundary where our current physics does not triumph, but merely whispers its own limitations into the unyielding, silent dark. The realization that we are completely isolated from the outer edges of our own solar system fundamentally shatters the illusion of our planetary security. For generations, we have treated the void beyond Neptune as a passive, empty moat, a quiet buffer zone, separating our warm, illuminated worlds from the hostility of the interstellar medium. But the thermal architecture revealed by the deep data forces us to confront a deeply unsettling paradigm shift. The Oort cloud is not a shield. It is a loaded ancient mechanism, heavily fortified with trillions of tons of kinetic energy, quietly suspended over our heads. And the trigger for this mechanism is governed by a timescale so incomprehensibly vast that human history is mathematically insignificant to it. To understand the hidden consequences of this frozen perimeter, we must expand our perception of time far beyond the lifespan of biological organisms or the rise and fall of civilizations. We must think in terms of galactic machinery. Our sun is not a stationary anchor. It is a star in relentless, violent motion. It is dragging the Earth, the inner planets, and the entire spherical mass of the Oort cloud with it, hurtling through the local interstellar neighborhood at nearly 500,000 miles per hour. But this trajectory is not a straight line. The solar system is locked in a colossal 250 million year orbit around the supermassive black hole at the center of the Milky Way. As we make this agonizingly slow journey around the galactic core, we do not sail smoothly. The physics of the galactic disk force our solar system to bob up and down, oscillating through the dense central plane of the Milky Way, like a ship riding massive, slow-moving waves. This vertical oscillation is the heartbeat of our cosmic environment, and it carries profound, potentially lethal consequences for the architecture of the deep dark. Every time our solar system plunges through the thickest, most heavily populated regions of the galactic midplane, we are subjected to a massive increase in the local gravitational tide. The combined mass of countless stars, giant molecular clouds, and invisible dark matter exerts a subtle but relentless pressure on the absolute outer edges of the sun's authority. During these transits, the delicate mathematical balance that keeps the outer Oort cloud in a state of dormant suspension is aggressively squeezed. The objects out there are holding onto the sun by the thinnest imaginable thread of gravity. When the galactic tide washes over them, millions of these frozen mountains lose their orbital footing. They are decoupled from their holding patterns, entirely stripped of the momentum that kept them hovering in the void. And once that delicate balance is broken, there is no physical force in the universe that can stop what happens next. They begin to fall. But this is not a sudden, violent rain. The distances involved dictate that this gravitational collapse plays out in excruciating slow motion. When a trillion-ton mass of primordial ice is dislodged at the outer edge of the perimeter, it does not immediately appear in our night sky. It begins a silent, invisible descent into the gravity well of the sun that will last for millions of years. This introduces a terrifying concept of cosmic latency into our understanding of reality. The cometary impacts that have periodically scarred the Earth, the catastrophic extinction events written into our geological record, were not random accidents of local space. They were the delayed, inevitable consequences of gravitational whispers that occurred in the deep dark when human beings did not even exist. The sky we observe today is fundamentally out of sync with the physical reality of the perimeter. We are living in a prolonged state of delayed reaction, utterly blind to the invisible avalanches of ancient matter that have already been triggered and are currently quietly falling toward us through the absolute dark. This latency fundamentally rewrites our understanding of the solar system's future. We know through precise astrometric mapping of our local stellar neighborhood that our isolation is temporary. The stars around us are also moving, following their own chaotic trajectories through the galaxy. In roughly 1.3 million years, a completely unremarkable dim red dwarf star named Gliese 710 will intersect our path. It will not hit the sun. It will not collide with the Earth. To the naked eye, it would merely appear as a newly bright, stationary star in the night sky. But mathematically, its trajectory is a death sentence for the current architecture of the Oort cloud. The calculations are uncompromising. Gliese 710 is projected to plow directly through the outer shell of our frozen perimeter, passing within 10,000 astronomical units of the sun. It will be the most severe gravitational disruption our solar system has experienced since its violent formation. As this rogue star forces its way through the dense, unseen ocean of ice, its gravity will act like a colossal, invisible plow. It will violently perturb the orbits of an estimated 100 million deep space objects. The delicate, silent equilibrium of the dark will be completely shattered. The rogue star will eventually pass, continuing its solitary journey into the void, leaving behind a heavily destabilized perimeter. And then the silence will return. For humanity, or whatever descendants might inhabit the inner system a million years from now, the immediate aftermath of the star's passage will seem perfectly quiet. But the mathematical reality is that millions of massive, ancient bodies will have already begun their long, inescapable plunge inward. The inner solar system will have been subjected to a delayed, catastrophic bombardment, a relentless rain of kinetic energy that will not arrive for another 2 million years after the star has vanished. The Oort cloud guarantees that our cosmic fate is sealed in absolute silence, long before we ever see the flash of impact. Yet, the sheer terror of this delayed machinery is matched only by its profound philosophical significance. The Oort cloud is not merely a reservoir of destruction. It is the ultimate uncorrupted archive of our own genesis. The inner solar system, the planets we study and the ground we walk on, has been violently sterilized by billions of years of solar radiation, volcanic activity, and tectonic recycling. The chemical history of the early Earth has been erased, baked away by the heat of the sun. We are living on a heavily redacted document, but the objects suspended out in the deep freeze of the perimeter have never seen the sun's warmth. They have been preserved in a state of absolute cryogenic suspension since the very first milliseconds of planetary construction. They hold the original raw ingredients of the protoplanetary disk. The deep infrared data suggests these bodies are rich in complex organic molecules, pristine water ice, and the fundamental chemical building blocks required to spark biology. This forces us to confront a deeply cyclical paradox. The catastrophic bombardments triggered by the galactic tide, the very events that possess the power to extinguish all life on Earth, are likely the exact same mechanisms that delivered the oceans to our barren crust 4 billion years ago. The mechanism of our potential annihilation is fundamentally identical to the mechanism of our creation. Furthermore, the boundaries of this archival cloud drastically alter our definition of where our solar system actually ends. Because the outer edges of the Oort cloud stretch so incredibly far into the interstellar medium, our gravitational influence physically overlaps with the perimeters of neighboring stars. Alpha Centauri, the closest star system to our own, likely possesses its own massive unseen reservoir of frozen debris. The astronomical distances separating us from our neighbors are not completely empty voids. They are regions where the very fringes of our Oort cloud gently brush against the outer clouds of alien star systems. In these silent, overlapping territories of deep space, the gravity of our sun and the gravity of neighboring stars cancel each other out, creating vast invisible zones of zero tension. In these zones, an incredibly slow, ancient exchange is constantly taking place. Can a block of frozen methane that belonged to our sun for 4 billion years might drift slightly too far, cross the microscopic threshold of gravity, and be quietly absorbed into the architecture of a completely different solar system. And conversely, we are unknowingly capturing alien mass. Deep within our own Oort cloud, suspended among the trillions of native ice mountains, there are undoubtedly countless rogue objects, frozen wanderers that were forged in the accretion disks of distant, long-dead stars, quietly integrated into our orbit. This means the solar system is not a closed, perfectly isolated bubble. We are an open, bleeding system, constantly shedding our ancient mass into the void and continuously absorbing the exiled debris of the wider galaxy. The perimeter is porous. It breathes. It is a slow, silent interface between our tiny, illuminated neighborhood and the vast, indifferent mechanics of the Milky Way. We are forced to accept that our reality is inextricably chained to the deep dark, governed by massive, invisible machinery that operates on a scale of time and distance that completely ignores the existence of biological life. The implications of this interconnected, delayed architecture strip away the final layers of human arrogance. We have spent centuries looking up at the night sky, assuming we were the center of a static, predictable clockwork. We assumed the dark was empty because it was quiet. We assumed the distances protected us because they were vast. But the mathematics of the perimeter and the faint thermal signatures bleeding through the void reveal that we are merely floating in the center of a dense, ancient mechanism that we can neither see nor control. We are standing in the middle of a cosmic intersection, utterly blind to the slow, relentless traffic of the universe, simply waiting for the inevitable consequences of mathematical equations that were solved millions of years ago. We are a species deeply obsessed with permanence. We build monuments out of stone, titanium, and silicon, carving our histories into digital servers and deep space probes, convincing ourselves that the ground beneath our feet is a stable, enduring foundation. We launch machines into the void, assuming our legacy will somehow outlast the biological fragility of our bodies. But the sheer scale of the Oort cloud and the agonizingly slow, relentless mechanics of its orbit force us to look directly at the temporary, fleeting nature of our existence. The Sun, the chaotic nuclear furnace that holds this entire, fragile architecture together, is not an infinite guardian. It is a dying star, burning through a finite, rapidly depleting reservoir of hydrogen fuel. In roughly 5 billion years, the physics of our central anchor will fundamentally and catastrophically change. The Sun will exhaust its core, triggering a violent expansion. It will swell into a massive, luminous red giant, expanding its atmosphere outward to swallow the orbits of Mercury, Venus, and likely the Earth. The inner solar system, our entire historical archive, the birthplace of every thought, war, and discovery, will be reduced to ash and consumed by the dying star. But the true ultimate tragedy of the solar system will not be witnessed here in the center. The final act will unfold silently, trillions of miles away, out in the frozen dark. As the Sun bloats and begins to violently shed its outer layers into deep space, its total gravitational mass will drastically decrease. The invisible mathematical tether that has held the outer perimeter in a state of suspended animation for billions of years will begin to slacken. The trillions of ancient, dormant bodies that make up the Oort cloud, the uncorrupted relics of our genesis, will suddenly find themselves untethered. The extraordinarily weak gravitational grip that barely bound them to our star will finally completely break. For the first time in 10 billion years, the architecture of the deep dark will begin to dissolve. The gentle galactic tide, which once only subtly nudged these frozen mountains, will become the absolute dominant physical force. The outer edges of the Oort cloud will be peeled away, swept up by the invisible, shifting currents of the interstellar medium. Billions of primordial worlds, rich with the frozen chemical potential of life, will quietly detach from our dying star and drift out into the galactic void as orphaned rogue objects. They will carry no memory of the star that forged them. They will retain no record of the warm, rocky planet that once harbored an intelligent species desperate to understand the dark. They will simply become anonymous wanderers in a galaxy populated by hundreds of billions of other dying systems. The great spherical shield that defined the absolute boundary of our existence will evaporate, leaving behind a fading, dense white dwarf star, surrounded by nothing but the cooling, sterilized cinders of the giant planets. The grand machinery of our solar system, a physical mechanism so vast that it took human consciousness thousands of years just to mathematically deduce its outer edge, will be completely dismantled. And the universe will not register this loss. The cosmic background radiation will not fluctuate. The local interstellar neighborhood will absorb our expelled mass without consequence. The terrifying reality of the perimeter is not just that it is massive, or that it is populated by a lethal, unseen reservoir of kinetic energy. The true terror lies in its ultimate, crushing indifference. The universe does not care that we learn to read its thermal signatures. It does not care that we map the trajectories of the dying comets or calculated the mass of the deep freeze. We are merely an anomaly of chemistry and time. A fleeting biological spark that emerged in the brief, stable window of a star's midlife. We evolved just enough cognitive capacity to build mirrors of beryllium and gold, to look out into the pitch-black void, and to recognize the colossal machinery poised above our heads. We possess the unique, agonizing privilege of knowing our exact place in the terrifying geometry of the dark. But that knowledge offers absolutely no salvation. It grants us no agency over the mechanics of the galaxy. The mathematics of the void will continue to operate with absolute merciless precision, entirely deaf to our observations, our fears, and our profound sense of wonder. We are simply brief passengers in a system that is quietly ticking down to its own inevitable dissolution. We are entirely powerless against the scale of deep time and the cold laws of astrodynamics. When the final mountain of ice eventually slips away from the dying, weakened grip of our sun and disappears forever into the galactic abyss, the space we once occupied will return to the absolute dark. The great chaotic story of our solar system will conclude not with a catastrophic, deafening explosion, but with a slow, agonizing fade into perfect, unending silence.